What's up, everybody? Coming at you live on a fine Monday evening. We're talking this review, and it's going to take a couple of sessions to get me through this thing. 'Cause it's a lot of stuff to cover. But we got this. We got this. You guys have been doing great, and keep up the hard work. Don't slow down now. It's going well. All right. So I'm going to cruise through kind of fast, but of course you can rewatch, pause, whatever you got to do to make it work for you. So let's take it from the top. Rectangular plot. What is the area? Gives you the length and the width. So A equals LW because it's a rectangle. And that's 2.5 times 8.5. And you just punch in the calculator. You should get 1.25 be miles squared if they ask for the units. Square miles. Good stuff. Easy enough. And this is just a little pro tip though. Always make sure your answer kind of makes sense. So 2.5, it's about 3. 8.5, it's about 8, give or take. And so 8 times 3 is 24. So if you get something in that ballpark, okay, I'm probably good. But if you got like 200 and something, then you'd be like, let's check. Okay. Here we go. Circle has a diameter of 17. Area, circle. This should be easy. What's the area of the circle near a square inch? So A equals pi r squared. The diameter is 17, so the radius is 8.5. So pi times, actually they want us to use 3.14 for pi, so 3.14, and then 8.5 quantity squared. And punch that out, enter it says to the nearest square inch, and that would be 227 square inches. Let's keep it rolling. Got a parallelogram. What's the value of x? Well, one of the properties of parallelograms is that opposite sides are both parallel and congruent. So these two things are equal to each other. So if things are equal, set them equal. There we go. And let's go ahead and get our x's together. Terrible life advice, but good math advice. And let's go. I'm going to use that joke forever now. This is 11 equals x. And they just double check to make sure you answered the question. Just find the value of x. Done. Diagram shows the floor of a living room. What's the area in square feet of a carpet needed to cover this area? So I'll just, since these are identical boxes, I'm going to take the area of the larger minus 2 times the area of the smaller. Okay, and I'm making my own little representations here. This is not official business. We'll call that the area total, something like that. All right, this just helps me visualize what's going on. So I'm going to take this base times height or length times width. And so this would be 20 by, and then 12 and 6 is 18, minus 2 times the area of one of these things. So that'd be 8 by 6. So 6 times 8. Okay, and that's my total area. And again, this is, you can just throw that in the calculator, no problem there. And you should come up with 264 when you're done. Let's keep it rolling. A band of gold surrounds the edge of a circular crown. It has a radius of 5 inches. Find the length of the band of gold to the nearest tenth of an inch. We're talking about something outside of a circle, the edge of a circle. And we're finding the length of it. So it's talking about length. We're not talking about area. We're clearly talking about circumference. So C equals either 2 pi r or pi d. So I'll put 2 pi r because they give it to us in radiuses, whatever. All right, radius is 5. So let's put 5 in for r. And 3.14 for pi. And we'll just multiply it through, and you should get 31.4. triangle XYZ might help us to draw a triangle here. So let's sketch a little triangle. And it doesn't have to be perfect. Sometimes the more random your triangle is, the better. But let's put in, okay, it says X. Let's put our letters on there just so we got them. So let's call it X, Y, Z. Okay. Now in XYZ it says XA is a median. In other words, I got to go median. Median means cut this side in half. We'll call this point A. And M is the centroid. So M is the centroid. It's this little part here where all your medians would intersect. You could draw them in if you want to, but you don't have to. And I'll just sketch that median in so we got it. All right. It says, what's the length in centimeters of XM? Ooh, I love these, right? What's the length of this? Let me give it a letter. Let's call it, I don't know, letter we haven't used. How about P? We'll call it P. All right, what's the length in centimeters of XM? Call it P. If XA, this whole distance here, is 129.3. Now, if you go to triangle segment sheet, okay, we're talking centroid, connects the vertex to the opposite midpoint, and here's the trick. Centroid cuts the medians into 1/3 and 2/3. Divide your total length by 3. And that's what you got to do on this one. So divide this total length here, 129.3. Just divide it by 3, and that will tell you each of those segments as we do it. So let's pull it in real quick. This is 129.3 divided by 3, and I get 43.1. Okay, so 43.1 is 1/3 of the thing. So that means this little length here, 43.1. But it also means, so don't get confused because this is just the short side. We also need the long piece. And the long piece is twice the short piece, right? Because it's cut in thirds. So this 1/3 here, that means 2/3 over here. So just multiply that by 2, and it gets us 86.2. Now 86.2 plus 43.1, that needs to make our total. And so XM rather, equals 86.2. Done. All right, find the perimeter in feet of the composite figure. When you want to find the perimeter, take a walk around. Don't count this little silly side in here. That's not part of it. It's not the perimeter. And so take a walk around. So let's see, 3 plus 5 plus 3 is 11, plus 3 more is 14, plus that's 18. Just add them all up. You can just walk around it. Bam, 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 bam. Done. All right, find the distance. Ooh, you guys love these ones. All right. Find the distance of a point, this point, to the line x equals 2. Now, this is the easy version, right? Remember the easy one? This is x equals 2. Now, let me just sketch what that looks like here. Let me plot it for you. You don't need to plot it, but sometimes it helps you visualize what's going on. So I've got, let's make another line here. Okay, so I've got the line x equals 2. Now the line x equals 2, as you know, is a vertical line. That's kind of a prerequisite thing here. Now, if I have a point, -9, so that's like way over here, -3, so it's like way over here. What's the distance to this line? So in other words, how far is it from here all the way to here? Well, you can go straight just by going across. So your x value right now is -9. You want the x value to be 2, so it's as simple as just saying, hey, because I'm going straight to the line, straight across, it's -9 plus 2, or -9 to 2. Okay, so it's from -9 to 0, and then 2 more after that. So your distance is positive, that's 11. So you don't even have to use a distance formula here, just count boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Bam. So don't get psyched out and think you got to do one of those complicated ones. That's a real simple one. All right, find the inverse of the statement below. Is the statement true? Remember, inverse, let's answer each part here. Let's find the inverse, then we'll do that. All right, so is the statement true? Let's do that. If all measures of a triangle equal, then the triangle is equiangular. Well, yeah, that's the definition, so Yeah, I hope so. All right, to make it an inverse, to make inverses, ready? Where are my grammar people at? You're going to put a not or a no or somehow negate the verb. So let's find the verb. Follow the measure of the angles are. Okay, are. There you go. Then find the other one, is. Okay, and just make them like negatives. Well, around here you can just say ain't, because it's fun, right? So if all the measures of the angles of a triangle ain't equal, then the triangle ain't equiangular. That's all I got, guys. All right. Is the inverse of the statement true? Let's think about it. If the angles aren't equal, then it's not equiangular. In fact, this is always true for because it's the definition. Definition is biconditional and all this stuff, but we won't get into that now. So inverses, just check it to see if it's true. Does it make sense? If it's not equal, then we'd not be equiangular, which is pretty evident. All right. In this right triangle, let's sketch a right triangle. It'll be fun. All right, here's our right triangle. And one of the measures is quite large. Here we go. So we've got a right angle down here, clearly. Angle E is, we'll call this angle E. It's the larger angle. And the vertex is C, so this has to be D up there. All right, it wants us to find the measure of angle D. So if this is 69 degrees, this is just 90 minus all that. And so this would be, because all the degrees add up to 180. So 90 plus 69 plus x, if you want to say it that way. But this is just 21 degrees, because 21 plus 69 makes 90. Woohoo! All right. Number 11 says write the biconditional of the statement and its converse. All right, so let's write a biconditional and a converse. All right, let's see. Let's do biconditional first. So biconditional says, let me start with x squared is less than or equal to 81. And you just go if and only if. Okay, if and only if x is less than or equal to 9ers. Okay, good stuff. Okay, and its converse. So the converse of that would be x is less than or equal to 9. And we'll put if then x squared is less than or equal to 81. So converse, remember, switches the order. So just they switch places here. Biconditional leaves them the same, but just puts this if and only if bit in the middle. So there's biconditional, there's converse. Now, is it true? Why or why not? Now, biconditional is only true if the original and the backwards version are both true. So if x is less than or equal to 9, does x squared have to be less than 81? So I'm just going to test both of them. So try to think of some counter examples to where it would not be true. So let's pick some x's that are less than or equal to 9. How about negative 100? Now negative 100 squared, though, is much bigger than 81, so this is false here. And once you have it false in one direction, it doesn't matter. Your biconditional's got to be false as well, okay? Because a biconditional means we test this way and this way. And so false, false. We're good. All right, law of syllogism. All right, law of syllogism to write a valid set of conditional statements for the following three in this form. Okay, if P then Q, if Q then R, so if P then R. This is the law of syllogism right there. So we would just say, if the bakery's open, then this person can buy buns. If they can buy buns, they can serve hamburgers. So, in short, if the bakery's open, we can serve some hamburgers. That's all you got to say. That's easy. All right, solve the equation below. Really, I'm not even going to say anything on this one. Okay, and you could just write like this would be your given step if they want you to show each step. This next one would be, that's distributive property. Okay, and let's get our x's together. Bad idea in real life, great idea here. Told you I'd say it every time. Okay, and this is both the adding property and the subtraction property of equality. And I'm shorthand in this one. And then this would be like a simplify step if you want to do that. And your last step, of course, is to divide by 5. So x equals 3. And then simplify. Anyway, x is 3. Well, let's keep it rolling. All right, in this triangle EFG, EF is 18, FG is 15, EG is 24. All right, for QRS, whatever. All right, congruency statement for the triangles. In other words, I've got to find the pieces that go together. Sometimes it's helpful to draw this thing. Let's see if we need to or not. Let's just do it. So I'm just going to make 2 triangles here. You can make them look kind of the same. Wouldn't hurt. Paste. There we go. All right, so let's see if we can associate which ones go with which. So EF is 18. Let's make this side 18. And this side will be 18. QR. QS is 15. FG, let's make this 15 and 15. And RS is 24. And this one is 24. So it's almost like a little puzzle. So this EF and EG, these both have the E in them, so this has to be the E right here. And so this is EF. And let's do the same thing on the other one. This is C. QR is 18 and RS. So R must be the key on this one. And then RQ, this Q goes there and S would go here. Yep. And just double check afterwards and make sure all of them look right. So EG is 24, FG is 15. And now you can make a nice congruency statement. Now congruency statement, all that is you just label the triangles properly in the right order as they go to each other. So do E, F, and G, that's fine, is congruent to, and then to go the same order, E, F, G, so this is going to go R, Q, S, that same direction, so they line up nicely. So R, Q, S. Cool. What's the included angle of JK and J? JK and J, the 2 rays there. Angle J. Now, if you want to name it with more than angle J, you could say like angle KJA, right? Because you got the 2 rays going in there. Okay, but that's all there is to this one. All right, anyway, find the value of x in the triangle below. This is clearly a thing, but the only trick on this one is the simplified radical bit. So let's do this thing. This is a squared plus b squared equals c squared. And so I get 4 squared plus 8 squared equals c squared. This is 16 plus 64 equals c squared. And then you're just going to add that up. You get 80 equals c squared. Now, what do you do from here? We're just going to take the square root of both sides to isolate c. So c equals radical 80. Now, how does 80 break down? Well, look for perfect squares that divide into 80. There are some, let's see, I know 4 will go, because 4 times 20, but another 4 could come out. So really, this is the same thing as 16 times 5. I think that's right, 16 times 5, yeah. So 16 times 5 is another way to say 80, 16 times 5, which is the same as 16 times rad 5. Equals C. Now I'm going to show you a cooler way to do all this stuff next year in Algebra 2. But for now, You'll just have to roll this way. Here we go. Just look for perfect squares that divide into that number. Okay, 16 is a great one, and this just turns into 4 rad 5. Super fun. Compare the measures of MO and PR. How did they compare? Well, according to your hinge theorem, this door is a little more open than this door. This door is closing. So therefore, because this one's open and these sides are fixed, that means that RP has to be shorter. So MO, whatever, MA. Let's try it again. MO is greater than PR. Okay, when you don't put the line over them, you're referring to the distance, their length. So the length of MO is longer than the length of PR. That was fun. Let's do it again. All right, use the given paragraph proof to write a 2-column proof. Well, shouldn't that be fun? Do I want to spend a whole lot of time on this one? Not really. All right, so let me just, yeah, I don't want to waste time on this one. But yeah, just go through each statement and write the reason on that one. If you want to see the entire proof, check the answer key because it lists the entire proof. But for me to talk through what's already written here kind of doesn't help anybody because you're not writing a proof, you're just copying down a proof in a different format. So let's move on. All right. Oh, this one looks like more fun. All right. It says find the centroid of EFG. EFG. How do you find the centroid of this with these 3 vertices? Now, you could draw a picture. You could graph this bad boy, and that may be your best bet on this one. Because your centroid is that intersection of the medians. But how would you do it without that? Now, one of the things you can do is use 2 points and find, like, let's say you didn't want to graph it or you couldn't graph it or it wasn't coming out evenly on that. If I can find the line that goes through these 2 points, and then I find the line that goes through, say, these 2 points, I've got 2 lines. And once you have 2 lines, wherever they cross, that has to be your centroid, because centroids is the intersection of the medians. Correction, these are not the midpoints. I just lied. You have to find the midpoints first and then do what I just said. So I think I'm going to opt to do a graph then, just to save us time. And sometimes you get to a problem like that, and it's just better to do that. So let's take a quick gander at the, where was I? Here we go. Let's take a look at these and see if we can do that. Wish I could take a shot of that one. This is -1, 3, 1, 1, and -3, 1. So let's plug this in. This is number 19. All right, so I'm just going to put these onto a graph. And I'm not going to label the graph, but you probably should if you're rolling through this one. So this is going to be E is at -1, 3. So put a little dot there. It's E. Nice. And it doesn't help, like, doesn't hurt to like draw a picture anyway, because then you get a good visual for where things should be, even if it's close to where the right answer is. Like that's a helpful thing. All right, and -3. So this is -3. -1, so it's this point right here. So what I want to do is find the intersection of these 3. Ooh, this actually is, because it's symmetric, it actually might be easy. All right, so let's connect our dots just so we can see our triangle. And then we will put our medians in. The medians might be pretty easy. So let's put our midpoints in first. So there's one there, clear as day. There's another one, clear as day. And when it works out real nicely and it's like on the points, this may work out very nicely for us. Now let's connect. Yeah, this is going to work beautifully. So we're going to connect the vertex to the opposite midpoint. And do it again. Vertex, opposite midpoint, vertex. Oh, this one works out beautifully. And notice how they all intersect. Let me slide this over just a little. Yeah, it's not going to cooperate. There we go. And so they all intersect right at this point right here, which is really easy to identify because it's right on the intersection. So it's -1, -1, and that is the answer. Okay, so -1, -1. So just have some graph paper ready for that test just in case one like this pops up. You'll be ready for it. All right. Let's soldier on. Let's get through at least this one, if not a little further. Determine whether the triangle below is a right triangle. Again, to prove a right triangle, Pythagorean theorem has to work. So just do 9 squared plus 9 squared equals 13 squared. And as you test that out, clearly it's not a right triangle because of the converse of the Pythagorean theorem. So nope, because 81 and 81 does not equal 169. Okay. Onward and upward. Plus, that's not a Pythagorean triple. Pretty sure. All right. Rosa must design a flag that will be exactly the same size as the triangle below. The flag will contain a right angle. She knows that she only needs to pick 2 other dimensions to make sure the flag is congruent to the triangle. List the pairs of dimensions Rosa could use to ensure the flag is exactly the same size and shape as a triangle. So pair of dimensions. All the pairs of dimensions. Whatever. All right. So if you remember all your different congruences with the right triangles, you can do those, or you can use like side angle side and things like that. So if I had A, B, and if I knew what that was congruent to, so if I have an AB, I've already got the right angle, so then angle B, and I've got BC. Okay, that's SAS. So if I had that, I would be good. So there's one of them. Another one would be, remember, we don't do angle side side because it's a naughty word, but we do hypotenuse legs. So let's do hypotenuse legs. So this is AC and AB. That's HL. Or you could talk about the other one, so AC and CB, for the same reason. So I'm just listing every one of them out because that's basically what they're asking. So that's HL. What about angle, angle, side? So that would be if I knew angle C, angle B, and then AB. Angle, angle, side. Okay. You could say it's leg angle or whatever, but no, you're good. Anyway, which other ones are there? Angle A, angle B, and AB. So there's one. That's the angle, angle, side. The only one I'm missing is ASA. So angle, side, angle. So that would be angle B, CB, and angle C. And the last one would be angle, side, angle the other way. So angle B, AB, and angle A. That's ASA as well. Good stuff. So much fun. All right, I think we got them all. Perpendicular, parallel, or neither. If you get it in slope-intercept form, really, you're just focusing on this part here. It would be really easy to move these around, switch them sides, and so this would just be y equals negative, 2/7 x minus 8. And now your slopes are clearly the same, so they are parallel. Okay. Easy enough, right? Let's take a look at this one. You use a diagram, find YZ. YZ. Why not Z, right? So we're going to find this length here if possible. And I've got XW is 13, so let's write that in there. 13. ZW is 12. Okay, this is interesting. And xy is 4. Okay, so this is like that one. This is 38-1, I believe. Theorem 38-1. Just make sure you got it. If you want to add that theorem to your postulate sheet, you're allowed to. I don't know why it wasn't included in there in the first place. But the essential key on this one, and a lot of you have missed this on that quiz there, is this and this, and kind of pairs up with this and this. Okay, so let's set up a proportion. They're like proportional to each other. So 4 is to 13. You can do it that way. Just like unknown value, we'll call it P because, I don't know. P is to 12. We'll cross multiply 13. P equals 4 times 12. And 4 times 12 is 48. And then we'll do 13. Let's see, 48 divided by 13. And that's 3.69, which I think that's 9/13. Yeah. So that's good. P is 3.69, roughly. Okay. Go out a couple decimal places, make it count. Good. So get that proportion. This one is to that one, so 4 is to 13, just like P is to 12. You're good. All right, so let's see if we get some triangles here. Which ones could form a triangle? Well, really, remember our triangle video that we did? The key is to take any two and add them together and make sure the other one is longer than the is long enough for the other two added together, and then subtract them too and make sure it's within that range. So let's do that here. So 8 and 9 is 17. That's longer than 10. We're good. 8 and 10 is 18. That's longer than 9, so we're good. And 9 and 10 is 19, right? And then the difference of all these is fine as well. Now let's take a look at this one. So this one's totally good. Okay, so again, just add and subtract each of those numbers and see. So 9 and 20, that's cool. 9 and 20, that would be 29, and this could make a triangle. That's fine. And really, you just want to take like the longest side to put the 20 down there and say, would 9 and 13 reach? That's probably a better way to look at it. Would 9 and 13 reach? Take your longest side here, 16. Would these two reach? So take the short two sides and see if they would add up to something more than this one. And this one would be, put 10 down there and see if 8 and 9 would touch. And they definitely would. So it looks like it's yes, yes, and more yes. They all work fine. State the converse of the statement. Converse, remember converse is just flip them, switch them. So if a quad has 4 right angles, okay, then it's a square. Okay, now this is just silly because rectangles would be a counterexample of something that has 4 right angles but is not a square. So the converse is false, but the original statement is true because all squares have 4 right angles. Okay, so original statement you could say is true. Converse, false. Good stuff. Let's see, sum of interior angle measures of a convex, irregular, quadrilateral. Okay, now sum of the interior angles you could remember is n minus 2 times 180. Okay, another way to think about it though, this is a helpful thing, is just to sketch out, oops, let's go here, just to sketch out a quadrilateral, make it rando. Okay, yeah, that looks trapezoidal, so let me buckle it down here. There we go. All right, now we're rando. Now, what you can do here is you can draw in a diagonal to make triangles. Draw in as many diagonals you need to fill up triangles. Now, how many triangles do I have? There are just two, and each one has 180 degrees of angle measure inside this shape. So, okay, so all the interior angles total up. This is 180 and that's 180, so it's 360 on the inside of that. Or you could plug in. N is the number of sides, so 4 minus 2 is 2 times 180, 360. Okay, same thing. All right, let's do just a couple more and we'll take a break. Triangular scarf has an area of, okay, triangle area. So first thing, before I don't even get in the problem yet, I'm just going to write A equals 1/2 base times height. All right, the base of the scarf measures 2x inches. Okay, so this is 1/2 times 2x, and the height is 2x plus 6. Awesome. And the area is 176. I'm going to just talk through it so you, I'm not going to write all the steps, but the justification steps. I'm just going to do it and talk through it. So first things first, we had one like this on a quiz or a test or something. But anyway, 1/2 times 2, those cancel. But now we have x times 2x plus 6, so this is 2x squared plus 6x, okay, is 176. Now get 0 on one side, so minus 176, and I get 2x squared plus 6x minus 176, and this equals 0. So the reason I got 0 on one side is to try to get that isolated and get ready to go. Because I'm going to use the power of 0 here in a second. So what I'm going to do now is look for GCF. That's my first step. So GCF is 2. So I'll divide everybody by 2. Okay, as long as I'm doing both sides, it's totally cool. But 0 divided by 2 just knocks everything out because this is 0 anyway. So 0 equals, and this is going to be x squared. Always look for GCF, guys. It makes your problems so much simpler. Look how easy this is now compared to how it was, you know. And then 176 divided by 2 is what? 88. So minus 88. All right, and that's factorable. And this would be minus 11, x plus 8. Set each one equal to 0, so x minus 11 equals 0, or, x plus 8 equals 0. So just solve those two things. So x equals, add 11, so 11, or x equals, subtract 8, so negative 8. So one of those two things it's got to be. Now, as we look at this one, oops, did I do the signs backwards? I did. Wow. I hope you all caught me on that one. This is going to be plus 11. This is a negative 8 there. Let me change that. Sorry about that. Hopefully you were paying attention and caught it. So when I subtract 11, it's going to be negative 11. And this was a negative 8 here. So this is now positive 8. Sorry about that. It's good to go back and check your answers too. Hint, hint. All right. Anyway, x minus a is 0. This is x is positive 8 now. This is negative 11. Now you can't have you have to reject that because you can't have like a negative length of a base of your scarf. So the answer is going to be 8 for x. Plug that back in. So the base is going to be 2 times 8. So that's 16. Base equals 16. And then the other one is 2x. So 16 plus 6. So the height is 22. Okay, and there's a better like detailed explanation in the answer key, so feel free to check that out as well. All right, let's keep on rolling. What's the included side of a triangle that's between these two angles? Well, it's the letter that they the side that they share. So it's going to be one that's probably easier just to sketch the picture. So PQR, an angle QRP, that's angle R. It's because the R is in the middle. And this is angle Q. And the side they share is QR. Included side is QR. Bam. All right, give a Pythagorean triple that is proportional to this. Well, you can either multiply all those by something or divide them all by something. And in this case, I would probably divide. So this is going to divide, let's divide them all by 2 or by 3. That's up to you. I'll divide by 3. So this is 6. I'll divide this by 3, it'd be 8. And this would be 10. Okay, could divide them all by 6 too, but here's an example. You could even write 3, 4, 5 because that's a variation of 3, 4, 5. So anything in that proportion of that form. Okay, we're getting there. Okay, we'll say this is a funny sign that comes up there, but it's really, they meant to say parallel. If you ever see that, that's what they're talking about. Write a 2-column proof. I will not write a 2-column proof. I'll just talk through it real quick just so we get a good basis of that. Remember, we've seen this one before. This angle is congruent to this angle, and because they are alternate interior, and for the same reason, these are congruent as well. And if you wanted, you have the vertical angles as well. Now, also says C is the midpoint of AE, so that means if it's the midpoint, then AC and CE are congruent, as well as this and this. But you don't even need all that. You could actually, oh man, you don't need much at all. You got vertical angles here. You've got those sides. You could do side, angle, 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 side. Anyway, you get a lot of options here for solving this one. But yeah, just walk through and pick your favorites on this. Okay, triangle has side lengths that measure this. What kind of triangle is it? We'll take your 2 short sides. Let's pretend for a second it's a, let's pretend it's a right triangle. And if it comes up short, then we'll know what kind of triangle it is here. So this is 7 squared plus 10 squared equals 14 squared. And this is going to be 49 plus 100 equal to, let's see, 14 squared is, why is my brain not working now? 360? No, that's not right. Man, I don't know, my brain's not working right now. So anyway, 14 squared is 196. Wow, I was way off. All right, 196. Just getting late, guys, sorry. So this is 149 equal to 196. So all we've really ruled out is that it's not a right triangle. But notice how the hypotenuse is too long when I square it. So if it's a longer hypotenuse, that means when I have my right triangle, this was too long. So this side is too long means it opened up more than 90 degrees, so therefore it's obtuse. And because the sides are different, you could say scalene. Okay? Obtuse and scalene. Use Pythagorean to figure out if it's right, and if it's not, then you can see if it's acute or obtuse based on that. Okay. Do we keep going? Yes, let's keep going. Okay, parallel, this is going to be 62. Opposite angles are congruent. And these, because their sides are parallel, these are same side interior or supplementary. So this would be 62 here at R. And then what, 118 here and 118 there. That's it. Use the LA congruence theorem. Now, leg angle is also known as leg angle. This is angle side angle. So you can just use ASA, that's equivalent. And just show each of those. Well, that's given. So C and is congruent to angle F. You just say given, and that's your angle. And let's see, BC is congruent to EF. And that was given as well. That's side. And the last one, you could just say the B is congruent to E given. So it's angle, side angle, and then just make your congruent statement at the end. ABC is congruent to DEF. All right, let's do, man, we're cruising. I want to finish this, but I don't want to finish this. All right, let's find one that's parallel and passes through the point. So when it says parallel, all we're going to do is steal the slope. Now, normally when you see the perpendicular one, you're going to want to convert it. But this time you're just going to steal that slope as it is, okay? So I'm just going to take this. I'm going to find the line that passes through that point. So I'll take the slope. So y equals mx plus b. Here's my x. Here's my y. Here's my m. I'm going to use this as is because it's parallel, not perpendicular. So 4 times -1 and plus b, and then this is a 1 here. So this is -4 plus b equals 1. Add 4, this is 5 equals b. So now, once you know b is 5 and m is 4, just write y equals 4x plus 5. Done. All right, we got some stores up in the city. The warehouse is equidistant from the 3 stores. So I've got dot, dot, and dot. I want to find the point such that that's the same distance from the 3 stores. So what does that look like? Well, let's go back to our triangle segment bit. If you want to be the same distance from 3 vertices, that's your that's this one here on the bottom, perpendicular bisectors. So I really need to just chop up one of these things and see where a couple of them cross, and I'll be good. So let's use perpendicular bisectors, and we'll be good. Let's see. Do we want to graph it, or do we want to do the other? That's a good question. Let's graph it, and we'll figure out our perpendicular bisectors. So this is 35. Let's pull this up again. Let's get rid of this guy. Okay, so for 35, we'll plot their points. Let's see, this is 1, -8. So go over 1, down 8. So this is 4, this is 5. So 8 is there. So we'll call, this one's A. And then 5, -8. So go over 5 and -8. So that's over here. That's B. And the last one is 5, 0. So go 5, 0. Oh, these work out really nicely. So cool thing is perpendicular. Let's find out the perpendicular bisector and see if we can make this work. Oops, where's my triangle segment? So you might want to study these, make sure you're good on them. But it extends from the midpoint at 90 degrees. So we're going to go from all the midpoints at 90 degrees and see if we can figure out this point. So let's find our midpoints first. Let's finish our triangle here. Here's all our supermarkets. And let's sketch in midpoints. Here we go. So they're pretty obvious on this one. And midpoint here would be here. And because they're dropping here, this is a midpoint here. So wherever we're going perpendicular, and we're going from the midpoint. So what does that look like? Well, that looks like this. Go straight away from it, 90 degrees. Straight away from it, 90 degrees. And this one, yeah, you can go off here. But the moral of the story is they all cross, and it happens to be on one of these lines. So that's kind of cool. It happens on the midpoint of AC. So what is that point? This is 1, 2, 3, and down 4. So this is 3, -4. And should be 3, -4. Let me just verify that before I tell you a fib. No, we're right. Okay, so this is 3, -4. So I recommend just like pulling in some graph paper, blank graph paper like this, just to kind of have handy, because it's nice to pull that in from time to time. All right, order the lengths from least to greatest. Remember, the biggest sides are across from the biggest angle, so don't be deceived by the pictures, guys. Don't get fooled. Let's pull in, this is 180 minus 45 minus 65 gives us 70. So this is 70, this is our other angle. So this is the greatest would be x, y. Oh, we're going to least to greatest, so let me make sure I put it in the right order. So x, y, the second biggest, the middle would be, well, y, z, and then the shortest would be x, z. Ooh, I can smell it. We're almost there. All right. Write a proportion to show this. Okay, well, A, B, so that's 6 is to 2. I'm just going from here to here, just like BC is to EF. Okay, so equals BC is 21, EF is 7. All right, now we'll just cross multiply. This is 42 equals 42 and check. Done. That's all you gotta do with that. Okay. Name a tangent line to the circle and identify a point of tangency. The tangent is the one that shoots out of the outside, so that is line OQ, I guess. And the point of tangency is P. All right. Oh, 2 more, I can smell it. All right, here we go. The pentagons are similar, find the values of x and y. So if they are similar, find a pair that go together. So let's find this. This is going to unlock it. Well, as soon as you see that, you're like, oh, that's half the size. You could set up a proportion here and say 12 is to 6 is x is to 3. But really, 12 to 6, that's half. So this x equals 6. And y is half of 18, so that's 9. Okay, but set up a proportion in other ones would be 12 is to 6, just like x is to 3. Not 16, 6. Okay, as x is to 3, cross multiply and solve. All right, last one. Ooh, we did it. All right, last one. It says base unit of 2, so go over 2. And you got a right angle, position PQR on the coordinate plane. Best spot is right in here. The height is 4, so just plop it right in there. And yeah, that's all I wanted. You could label your coordinates and stuff, but that's it. So good job, everybody. Go get some rest.